Turn on your kitchen faucet. Watch the water rush out, clear, odorless, seemingly pure. We do it a dozen times a day without a second thought. We brush our teeth with it, cook our pasta in it, and fill our glasses with it. We trust it because we're told it's safe. After all, we live in a modern society with strict regulations, right? The short answer is yes. For the vast majority of Americans and residents of developed nations, tap water is legally safe to drink. It won't give you an immediate illness. It is treated, disinfected, and monitored. But there is a difference between safe enough to survive and optimal for a long, healthy life. The question we need to ask isn't just, is it safe? But rather, is it clean enough to support my longevity and vitality? And the more we learn about what's actually in our water, the stronger the case becomes for taking that extra step: filtration. Today, we're going to look beneath the surface. Let's start with what's working. Municipal water treatment is one of the great public health achievements of the last century. We've virtually eliminated waterborne diseases like cholera and typhoid that plagued our ancestors. The treatment process typically involves coagulation to remove dirt, sedimentation, and filtration through sand and gravel. Then comes the critical step: disinfection. Most municipalities use chlorine or chloramine to kill bacteria and viruses. This is a life-saving process. Without it, drinking tap water would be a gamble with pathogens like E. coli and Giardia. So, when you drink your tap water, you are not ingesting active, dangerous pathogens. That is a fact. But here is where the story gets complicated. That chlorine that saves us from bacteria, it reacts with naturally occurring organic matter in the water, like decaying leaves. This reaction creates byproducts called trihalomethanes. These are chemical compounds that, over a lifetime of exposure, have been linked to increased cancer risk. Again, the levels are regulated, but the science increasingly suggests that acceptable levels are not necessarily optimal levels. Now, let's talk about what treatment plants don't effectively remove. The first category is heavy metals. Lead is the most notorious. Even low levels of lead, especially in children, can cause irreversible neurological damage. It enters the water not from the treatment plant, but from the pipes and fixtures in your own home or the distribution system. For homes built before 1986, the risk of lead pipes is very real. A water treatment facility cannot control your home's plumbing. Then there are synthetic chemicals. Pesticides from agricultural runoff, industrial solvents, and pharmaceuticals. These are called emerging contaminants. People take medications, their bodies process them, and those chemicals end up back in the water supply. Treatment plants were not designed to remove these complex chemical compounds. We're talking about trace amounts of birth control hormones, antidepressants, and antibiotics. We are, in effect, unintentionally drinking a chemical cocktail that has never been tested for long-term human safety. We cannot ignore microplastics. Studies have found microscopic plastic particles in nearly every water source on Earth, from mountain springs to municipal taps. These particles can carry harmful chemicals and accumulate in our bodies. The long-term health effects are still being researched, but the preliminary data suggests they may contribute to inflammation and endocrine disruption. And then there's the fluoride debate. Fluoride was introduced to prevent tooth decay, and it has been effective. However, the World Health Organization states that high levels of fluoride can be toxic to bone and the developing brain. The question is not whether fluoride is good or bad in isolation, it is about total exposure. If you drink tap water, brush with fluoridated toothpaste, and consume processed foods made with fluoridated water, you are potentially exceeding the intake that optimizes bone health. The issue isn't panic, it's precision. We can no longer assume that something the government says is acceptable is the ultimate benchmark for our personal health. This brings us to the practical solution: filtration. This is not an alarmist call to buy expensive bottled water, which, by the way, is often just repackaged tap water and contributes to massive plastic waste. Instead, the case is for a high-quality, certified home filter. Not all filters are created equal. A simple carbon pitcher filter can effectively reduce chlorine, bad taste, and some lead. A reverse osmosis system can remove a much wider spectrum of contaminants, including heavy metals, nitrates, and many pharmaceuticals. When choosing a filter, look for certifications from organizations like the NSF, which test filters against specific contaminants. Think of a water filter as an insurance policy. It's a low-cost, one-time investment that provides daily peace of mind. It's about taking control of what enters your body rather than relying solely on an aging infrastructure that was built for a simpler time. We drink water to live and to thrive. We drink it to flush toxins out. Yet, if the water contains trace toxins itself, we are undermining that process. Drinking filtered water is not about fear. It's about wisdom. It's about minimizing the background noise of chemicals so your body can focus on repair and longevity. In the end, you can't control the air quality outside entirely, and you can't control the food supply chain completely, but you can control the water that passes your lips. That small act of filtration is a powerful statement that you value your health enough to invest in the most basic, essential nutrient: clean water. Thank you.